converted index. We have discussed an example also. And also we have seen intersection operation, where we perform intersection of two different terms from the different documents, okay, from a set of given documents. And also we have seen, one second. And also we have seen uh, different issues or different problems when we perform the tokenization technique, because in tokenization we cannot separate, or we cannot uh, split the hyphenated terms or apostrophe terms, or name of some places or country. So all those issues we had discussed yesterday. And in order to solve the problems, we have introduced language identification also. Okay, what's in language identification? And you can see here, okay, so language identification. So here we are going to perform normalization of the terms. Normalization of the terms. And we also have seen yesterday stop words. So what are stop words? Those are the words, or those are the terms which appear in the document, but it is of less value or little value in finding our relevant, or in retrieving our relevant document. So examples you have seen yesterday: and, is, or, are, was, where. All those are examples of top words. And token normalization, see, we have seen this one also yesterday. See here, we are going to map those different forms of the same word. Now, for example, hyphenated word, anti-discriminatory and anti-discriminatory. These two words will be mapped, and our language identification will consider that this as single word. So when you construct the token for anti-discriminatory hyphenated word, when you write anti-discriminatory to this word, it will read this hyphenated word also. Okay. So this is mapping onto the same word, okay, in both the document text and queries, so that we can easily search the term for retrieving the documents. Now, stemming and lemmatization. So we will see stemming and lemmatization today. So one second. Okay. Now, stemming and lemmatization. We say, for example, yesterday when I say that all the words will be converted into a base form of the verb, or base form, so that it will recognize all the different forms of the same word. So some words you can see here, organize is the base form. Okay, organize is the base form. So when you write organizes, when you write organizing, so these two words will be mapped to organize. So when you write token for organizes, or when you write a token for organizing, you can write organize alone, because with language identification we have normalized this organized word and its different forms. Similarly, for democracy also. For democracy also, you can see here democratic, democratization. So all these are different forms of words. So base form is democracy. So you can map into onto democracy. And for example, the purpose for stemming and lemmatization is normally to reduce all the different forms of a particular word, and also uh, derivational words. Okay, uh, you can see examples here: am, are, is. So suppose when you consider this, actually these are stop words, but when you consider this as a single term, individual term, the base form is be. The base form is be. So whenever the terms this are present, you will be converting into be. Okay, when you consider stop words, if you don't consider stop words, then all to uh, convert into base form of this particular word. And for example, car is one individual token, cars. This is its derivational form, cars and cars. So we have all apostrophe here. Okay, we have apostrophe here, we have apostrophe here, we have plural form here, and this is the original form of the word. Those are the derivational forms of the word. So all these derivational form we are converting into the base form car. We are converting into the base form car. So this kind of converting the particular word into the base form of the word is known as stemming. Okay, sorry, lemmatization. That is known as lemmatization. So lemma means base form of the word. Lemma, Lemma. Lemma means base form of the word. So converting your derivational form of the word into a common base form of the word is known as lemmatization. Clear? So lemma means base form of the word. Okay. And whereas in stemming, what we are going to do is we are going to chop, we are going to remove the additional word which is added to the base form. For example, replacement. So replacement we have added ment, 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 right? So replace is your this original word. So from replace we have added replacement. So you can stem it or you can chop it uh, meant, and your original word will be replaced. So like that, and we will see some more examples there in the next page. So before that, one more example is given here. So suppose when we do the mapping of the text or the mapping of the terms, so this is the word actually given. The boys' cars are different colors. So what we have done here is the remains the same. Here, when we perform the normalization or when we perform stemming and lemmatization, but in this particular statement, this apostrophe will be removed and we will put token as boy. So we will convert the token as boy. So the boy. Cars. Cars is a single plural form. So you will remove s and the original form is car. So car. Then r. R is the B form of the verb. So this B form, original form is B. These are the derivational forms. So we are converting into the original form and different. So here we perform stemming. So this different, differ is the original form. So different is the derivational form, differ is the original form. So we will remove this one and differ remains here. So colors. For colors also we will remove s, so, and will be converting into the singular form color. So the boy car B differ color. So the result of this given statement, after we perform the mapping of the terms, we may get a result like this. The boy car B differ color. Okay, so we may get a result like this. Now, so here stemming. Stemming refers to a crude heuristic process that chops off the ends of words in the hope of achieving this goal correctly most of the time, and often includes the removal of derivational affixes. So affixes means whether it is a prefix or whether it's a suffix. You can remove. So derivational affixes you can remove, and also end of the words that chops off ends of the words. So that kind of technique, that kind of method, in order to get a normalized token, is known as stemming. So here, some words ends with SSES. For example, caresses. So for caresses, we can remove this ES, the N word. ES we can remove, and result we can write caress. Okay, and IES. There are some words which end with IES, so that can be removed and it can be replaced by I. So ponies, ponies we can write pony. And when there are words which ends with SS, so we cannot perform anything here. So remains the same. Caress, caress. And for S, if there are words ending with S, we can remove the S. For example, cats, cat. Okay. So these are some examples. So stemming, as I say, stemming here, what you have to remember is it is the process of chopping off the ends of the word, or we remove the derivational affixes. It can be prefix or it can be suffix. That prefix means the word which is uncomfortable, for example, un, that is affix. Sorry, prefix. I'm giving this an example, okay? So prefix, suffix. So when you chop off or when you remove the derivational affixes, that should not change your meaning. If it change your meaning, then you cannot perform that one. So this thing you have to keep in your mind. Okay. This thing you have to keep in your mind, because when you remove your derivational affixes, for example, replacement, meant, M-E-N-T, meant is the suffix. So if we remove suffix meant, replace. So replace does not change the meaning of replacement, right? So that means we are replacing something by replacing a thing by some other another thing, right? So the original meaning does not change, but when you remove the derivational affixes, that should not lead to the change of the meaning of that particular term. Okay, and coming to
Excuse
lemma.
me, some
Yes.
students are waiting. Please let them in.
Okay. Okay. So now when it comes to lemmatization, as I told you, lemmatization, lemma means base form of the word. So when you perform lemmatization, we will be converting, or we will be removing the end of the word, so that we can return to the base form of the verb, base form of the word, not verb alone, any kind of word. So we can remove, or we can return. One second. Atul Sharma, already I admit him, but still, one second, let me check. Okay, now it's updated. So, uh, lemmatization refers to doing things properly with the use of a vocabulary and morphological analysis of words. So, we will be having some analysis also. Normally, aiming to remove inflectional endings only and also to return the base or dictionary form of the word, which is known as lemma. So you see a token here, for example, so, SAW, so. So stemming might just return S, whereas lemmatization would attempt to return either C or so, depending on whether the use of the token was a verb or a noun. So do you see the difference? Lemmatization. So lemmatization means what? Returning the base form of the verb or returning the base form of the word, right? So when I write SAW, so the base form of the verb, this is a verb, right? When we consider show as a verb, we can return C, SEEC. But if show is a noun, we will be returning show. Okay, we will be returning show. So that is what it says. Lemmatization would attempt to return either see or so, depending on whether the use of the token was a verb or a noun. So if it is a verb, it will return see. If it is a noun, it will return show. But in stemming means chopping off, right? Or removing the derivational affixes. So suppose when you consider show, we may chop off the end of the word, okay, W, or we may chop off AW. So sometimes this may return on the S. So when you perform stemming or lemmatization, you have to see the term properly. Okay, you cannot directly simply perform, oh, let me perform stemming or let me perform lemmatization. You should not do in that way. So you have to see the term properly, whether it is a verb, whether it is a noun, or if I do stemming, will it return a meaningful term, or whether if I perform lemmatization, will it return a meaningful term? That you have to consider all these factors when you perform stemming and lemmatization. Okay, one easy example is given here. Okay, so, so SAW, if you perform stemming, sometimes it might written only S after chopping off the end of the words. So this does not give a correct meaning, or this does not have a meaning. This is not a meaningful term. Whereas if you perform lemmatization, if it is a verb, it will return C. If it is a noun, it will return this word directly. So according to this, we will perform lemmatization for this particular word. And there are some stemming examples given here. So operate, operating, operates. Okay, operate, operating, operates, operation, operated. These are all derivational affixes. Sometimes this may return oper. Okay, but the original word is operate. That is what it is said here. However, since operate in its various form is a common verb, we would expect to lose considerable precision on queries such as the following. So, operate is the what? Meaningful word. So, when you perform stemming, you have to check carefully that whatever the word which is um, normalized should be meaningful and should be common or should have its various forms. Opera does not have various forms because when you perform stemming means what? Chopping off the end of the words. You can chop off this, you can chop off this, you can chop off this, and it returns opera. Okay, but opera is not the word which is meaningful and which we can retrieve from the document. So, operate. Operate, it has various form. Operate, operating is one form of operate. Operates is one form of operate. Operation is also operates one form. Operative another form. Operatives another form. Operational is also another form of operate. So when you return, operate is the correct. Okay. So operate is the word which we can return for this particular example. Okay. And operational research, these are, one second. Now, some examples we have seen: stemming, lemmatization, we have seen. So, see here for this example also: operational and research, operating and system, operative and dentistry. So, when you, for this particular query, if offer is written, if offer is written, this does not give you the correct meaning. So you cannot perform or you cannot process the query. But if you return operate, it can perform the query operations. You can process the query operations. Okay. So these things also you have to check while performing the stemming and lemmatization. So for a case like this, we may use a lemmatizer, but it may not completely fix the problem because a sentence with the words operate and system is not a good match for the query operating and system. Okay. So what does it say? Why do I say this one? Sometimes when you return and operate, so it is based on the query. It is based on the query. So the combination of the query may not be matched. That is what it is said here. The combination of the query may not be matched when we return operate also. Okay. So there may be, they are telling that this may not completely fix the problem. So lemmatization also may not fix the problem completely. That means 100% we cannot fix the problem because issues may be there. Because you see here, operate has certain meanings and it has certain different various forms. Okay, so operating system, when you consider operating system, operate and system, so we have to check whether it is matching or not. Operative, if you write operate and dentistry, it is matching. Okay, if you write operating, operate and matching, sorry, operate and dentistry they do operations, or operate, if you write, it is matching, right? So operating system is, if you consider that as a subject, we cannot write operate and system. Okay, so this, when you return operate, this will, uh, the meaning will change. So operating itself we have to put. That is what, it does not solve 100% completely, but it is, it can be effectively used. So lemmatization can be effectively used, but it does not solve 100% completely the problem. Clear? Because when it this operating system, if you consider that as a subject, and if you write operate and system, so the meaning completely changed, right? So for those cases, we will use operating itself. We are not going to perform any lemmatization techniques here. Okay. So the queries, if it is maths or not, you have to check when you perform lemmatization or when you perform stemming. So lemmatization example which I just explained now, all these are forms of operate. So operating is one form of operate, operates also one form of this one. So all this, if we perform lemmatization, we can convert to operate. Clear? So even though if we convert into operate, there are cases. Okay, there are cases. Some cases may be there. Even if we perform the lemmatization technique, this may not fix the problem completely. Okay, so the query may not match, so the meaning will be changed. Clear? So once again, let me just brief the chapter topic of indexing, inverted indexing. So inverted indexing is nothing but we are going to construct a file, inverted file, where it has the location of the text. It has the locations of the text in the document or the set of the documents. So we have posting list, we have dictionary of terms. Now steps. So these steps here it is also there. First, document to be indexed will be identified. This is the document. Suppose if you consider Friends, Romance, Countrymen, this is the document. The second step we need to do is tokenization. Tokenization is just splitting your terms into individual terms. The friend is one separate token, Roman is one individual token, Countryman is one individual token. Next, linguistic pre-processing. So linguistic pre-processing, so we will be taking out all those plural forms as and all those capitalization, that means capitals which we put in front of for this particular romance. R is capital, friends F is capital, countrymen C is capital. So everything we have normalized and we have put into like this: friend, Raman, countrymen. So plural we have converted into singular. And finally, we will be converting the inverted index. So this is nothing but your location and this is known as postings. And this side, friend, Roman, countrymen, this is nothing but your dictionary. So the complete file is known as posting file. Example is shown here: Brutus, Caesar, Calpurnia. So Brutus, we have the locations of Brutus. It is there in document 1, document 2, 4, 11, and so on. For Caesar also, for Calpurnia also, we have different locations. So this part is postings, this part is dictionary. So now we have two documents here and we have certain words or certain set of terms are given here. All the terms we have written, and document 1 is represented, the document ID is 1. For document 2, we have represented the document ID as 2. So all that has been written here and we have arranged in alphabetical order, and the final inverted file is given in the rightmost side. So this is nothing but your terms, document frequency. So I have already explained what is the difference between document frequency and term frequency. Document frequency is counting the number of documents, okay, for that particular term. So ambitious. Ambitious is present in document D1, D2, sorry, D2. It is not present in D1. So only it is present in D2. So number of document is 1. That is what I am writing here, document frequency. So similarly, you count all the document frequency for this respective terms. So all those frequencies are written down here. and the respective posting list. Posting list means which location to which location. Ambitious is there in D2. So D2, the document ID is 2. So B is there in 1. B is there in D2, document 2. Document 2, document ID is 2. So I have written down all the document IDs here. So if suppose for Brutus, it is there in D1 and D2, document 1 and document 2. So I am writing here 1 and 2. Okay. So this complete file is known as inverted file or posting files. In this example, you can just go through. We have seen in last class. And for this also, we have seen this. I have asked you to solve this one. And processing Boolean queries is nothing but performing the intersection operation. So for E, the terms given as the query, so this term, and we have two terms here. So for this term, we have to locate in the dictionary or in the document where thus it is there in D1 or D2, we will be locating, and finally we will be retrieving the position. Okay, retrieving the postings. So Brutus is there in 1, 2, it's given here, California is given here. Intersection means what? Common to both. Common to both. So to which documents are common in both the terms. So term Brutus is present in D2, term California. Brutus and California is present in D2. Brutus and California is present in D31. So intersection means common to both. So these two documents are common for this query. Next, algorithm. We have seen explanation about the algorithm. We will be checking if the two posting lists are not empty. Then we will check the respective document IDs. If the document IDs are equal, we will return the result. And we will increment the position to next position. Otherwise, if the document IDs are not equal, then also we will move one position next to that particular postings document ID. Okay. And finally, we will return the answer. And for n intersection of n terms also we have seen in last class. The same process will be done, but here instead of having two posting lists, we will have a number of posting lists because we will have n terms here. An example also we have seen here for query processing. So this is how you solve the query. So for this particular query, the return result is document 1, document 2, document 3, and document 8. Tokenization, we have seen splitting or defining separate individual terms from the document. And also in tokenization, we will be checking the terms, whether we will be checking the punctuations and all, we will be checking here. And some issues also we have seen, the terms having apostrophe, the terms having hyphenated words, the terms having space. So all those things we have seen here, and those issues will be solved using the language identification technique. And stopwords we have seen. So these are word terms which is commonly occurring in the document, but this does not have that much importance to the retrieving of the document. And these are the stopwords. And finally, stemming and lemmatization we have seen. Okay, lemmatization, just bringing to the lemma form, that is lemmatization. stemming, chopping off the end of the words, or derivational affixes. Now, uh, you just see this one. One second, okay. For this also, I will send you the assignment, but before that, you just see one question which I will be sharing now. Okay, so uh, construct inverted index for the following. So this one, constructing the inverted index, so you can easily do this one. So I do not ask you to remove the stopwatch in question number one. So you can put all the stopwatch in question number one. And for question number two, given the following document, list out the stopwatch. So two documents are given, D1 and D2. So if you conflate two or more descriptions or ideas, or if they conflict, you combine them in order to produce a single one. So D1, you have to find out the stopwords, and from D2, you have to find out the stopwords. Okay, this is the next question. And question number three, for question number three. Question number three, consider the following documents and process the query. So this is exactly what I have given in class to solve this one, okay. English tutorial and fast track, learning Latin semantic indexing. So this is the query given. Mm, and you can solve using the query. Okay, so this is these are your questions for your assignment. And from this question, I may add some questions or I may change some questions, because question number three we have done already in class. So I may change question number three and others. Okay, or I may add some questions. Okay, question four or five questions I will be giving you. Four or five questions I'll be giving you so that you can solve it and you can submit. So for every topics we did in class, we will be having assignments for it. Okay. So for today, let us wind up here. I'll take your attendance now because at 1 o'clock I have a meeting at college. So we will wind up for today. If you have any doubts in today's class, you can ask me. So I'll take the roll call again. Just give me 1 second. So roll number one,
Present, ma'am.
roll number two,
Present, ma'am.
roll number three,
Present, ma'am.
roll number two. So what happened? I think this is your first class.
No, ma'am. This is my second class.
First class roll na ay roll ko the di ko magting.